On the east of Interstate 35, it's a very sticky high clay soil. So what Texta does, normally we treat it with the lime. Lime going to reduce, we call PI, plasticity index. However, high PI clay soil has sulfate already. Sulfate basically is a gypsum. So if you have the sulfate in the soil, when you add in lime, lime going to react with the gypsum.
Some of the reactions between lime or cement with the soil sulfates and also soils itself cause a compound called ettringite. This ettringite, whenever it gets hydrated, it actually doubles up its volume. So whenever that happens in a soil, the pavement starts heaving up and you will see a lot of bump-related cracking happening on the pavements. So the pavement has to be constantly repaired.
Sulfate issue is very localized. So most of the time you're going to miss the sulfate. So that's why we develop another field sulfate detection method. So we're using that device, identify the sulfate location first. Then we do take a sample from the area which has a high sulfate soil. Then we take the soil to the lab.
In the lab, we looked at different treatment methods. The two treatment methods, one of them is lime with extended mellowing. The other thing we did is cut down the lime, add fly ash. And both of them showed good promise in our lab studies. So from the lab, we go into the implementation where we have a test sections at one of the projects at US 82 Bell in that area. We have two test sections, one with the lime with extended mellowing, the other one with lime and fly ash treatment. And then we also, for comparison, we have a control which is using the traditional lime with one-day mellowing. And we've been monitoring for a couple of years now, and we're looking at roughness from the profiler studies and any visual movements of cracking, all those things we are documenting.
Our main job duties include going there every month and do all these tests. Some of these tests are like elevation survey and to test the modulus of the pavement using falling weight deflectometer and surface profiler and ground penetrating radar. So these three techniques give us how the pavement is behaving inside and the modulus of the pavement, the stiffness of the pavement. All of these we have recorded through these 3 years.
Majority of the sections are performing very well. We have one or two areas slight heaving, but other than that, it's really working very well. So anytime if you have built a road that has less, we call roller coaster rides, that is a pretty good road for safe riding, and gives a lot of good comfort for the public. So you have a very smooth ride, so that will really help the public's perception about the district in that region. Some of the districts that we are working where we have high sulfate soils, typically they spend several millions of dollars per year on repairing the roads that are distressed by this heaving. So with new solutions, what we are proposing, we can cut down this sulfate heaving. Again, I think that will help us in cutting down the maintenance costs for the district.